The shape of the HCl4 is best described as a, so we have four options: square tetrahedron, square pyramid, and seesaw. So how we can draw this HCl4? HCl4 we can draw like this. This is the sulfur and 4Cl is there. So 1Cl can be this side at the planar, and 1Cl be down, 1Cl up, and this is the lone pair. So it gives the structure of a structure like a seesaw structures. So in this, what is the option correct? So we have option correct, seesaw structure for this question. Among the following atomic orbital overlaps, the non-bonding overlap is. So in this option, what is the non-bonding overlapping? So this is overlapping, we can see. In this case, this lobe is overlapping with the middle portion, this one. So this is a non-overlapping portion, most probably this is overlapping properly. This also overlapping with the s orbital with the this d orbital. So this is also overlapping. This is the ND. We can say this is the negative overlapping. This is the negative overlapping, because this is the negative, this is positive, so this will not overlap. The lobe size will be reduced down. So this is the negative overlapping. So this is the positive overlapping. This is again positive overlapping. This is the negative overlapping. This is your non-bonding. So our answer is correct. Among the following complexes, the one that can exhibit the optical activity is. So CuCl6, 6Cl is there. So we have 6 ligands. So this is not possible. This will give a symmetry. En, this is the bidental ligand, 4Cl. Again, this is also not possible. Cis and trans, En, again 2 is the Cl. So we can see in this structure. So let us write, this is the CO, and we can write O, and this is again we can write CO, like this is there. So again we can write like this cross. So one you can draw this one, this is the En, one you can draw En, this is the Cl, and if you take the mirror image, so this is the Cl, this is the Cl, and this we can draw En, and we can write En this side. So this is the cis position. So this gives you optical activities. This is correct. These are enantiomer to each other, and we can also draw this is trans. This is the En. This is En, and Cl is this side. This is the trans position. So this will not give you the optical activity. So our answer in this case is this is correct. pK of the oxo acids of chlorine water follows the order. So this is the oxy acids of the chlorine. So we'll see which has the less oxidant states. That will determine the oxy acids of the pK of the oxy acids of the chlorine. So we see HClO4. So this will give you a +7. This will give you 6 plus -1. So it is give you +5. This will give you +3. This will give you +1. In this case only this is giving. So out of this 4 options, this has the lowest oxidant state. So pK value will be what? Here, very less. So in this case pK value is your +7 oxidant state, and this is your very high. In this case very high. So this is high means pK of this is very high, and K value of this is very low. So this option is correct. The packing efficiency of the FCC, BCC, and the PC lattice follows the order. This is once again easy questions. So we know the packing efficiency of FCC. So FCC is how much? It is 74%. And for BCC, it is again, if you know, 68%. And for this is a PC. PC is a simple cubic, primitive cubic. So this is your how much percentage? It is your 52%. So we can determine which have the more packing efficiency, definitely FCC. So answer is our A. The ratio of the RMS velocity of hydrogen at 50 Kelvin to that of nitrogen at 500 Kelvin is closest to. So we know V RMS is equal to 3 RT by M. So R is constant, 3R is constant, we'll take T by M. So velocity of RMS of hydrogen and V RMS of next is your nitrogen. So 2 ratio hydrogen, so T by In this case, hydrogen by molar mass of hydrogen and multiplied by nitrogen by temperature of nitrogen. So we will get answer. So hydrogen is 50 by 500, we can write. So 50 by 500 and molar mass of nitrogen is 28 by 2. So on solving, this becomes 14, this is cancelled, this becomes 10, and this is the 7, and this is the 5. 7 by 5. It's the square root of 7 by 5. So if you solve it, so on solving, you will get answers. How much? It is nothing but it will be your 1.18 answer. So in this case, our answer is this correct. The molecule with the highest dipole moment among the following is. These are the 4 molecules. To find the dipole moment, we will see the electronegativity difference. So we know for nitrogen is how much? It is 3, and hydrogen is 2.1. So in case of ammonia, the electronic difference is very less. It is 0.9. If you take the fluorine, it is 4 value. So difference between the nitrogen and fluorine is 3 and 4 is, again you can say 1. It is more than that. Dipole moment of NF3 is more than ammonia. Again for carbon, so carbon is 2.5, oxygen is 3.5. So again difference is 1. So almost they are same. So carbon is same here. In case of D, so hydrogen is 2.1, but fluorine is 4. So there is a more electronegative difference between the HF molecule. So dipole moment will be highest in case of HF, and remaining is the lower dipole moment than HF. So this is the highest dipole moment, remaining is the lower than that of HF molecule. The most stable Lewis acid and base adduct among the following is H2O BCl3, H2S BCl3, H3N, ammonia and BCl3, and phosphine and BCl3. So in these cases, electronegativity of this case of ammonia is, so in case of electronegativity, oxygen is higher than that of nitrogen, but it has 2 lone pair, it has 1 lone pair, so their electronegativity value is somewhat less than that of ammonia. So only ammonia will form the Lewis acid base adduct as compared to water. So this is the most stable product than this one. This is the most Lewis acid than that of ammonia. So this is the better product. The reaction of D-glucose with ammonical silver nitrate produces. This is the question number 49. So D-glucose, we know this is the CHO, and the last part is CH2OH. This is the D-glucose. In presence of tolerance reagent, that is the silver nitrate, so this will oxidize into carboxylic acid. This is not affected. So if you compare which is correct, this is again wrong answer, this is again wrong answer, this is correct answer, this is again wrong answer. So our answer C is correct. The reagents used for the conversion of benzene diazonium hydrogen sulfate to benzene. So this is our N2, and this is your hydrogen sulfate. So this is the positive, this is negative. And in this case, if you use water, so this will convert into phenol. This will convert into your phenol. But if you use H3PO2 plus water, so this will give you, in case of H3PO2, this will give you directly benzene. This is the only region which gives benzene. H2SO4, no, it won't give. In case of CuCl, so it will convert into again chlorobenzene. So we won't get benzene. So our option to convert it to benzene is only this. This is only giving benzene. The major product obtained in the reaction in toluene with 1-bromo-2-methyl propane in the presence of anhydrous AlCl3 is. This is the question number 51. So what is this compound? This compound is, again we can write toluene is, this is the toluene CH3, and we are going to react with the putting Br and in presence of anhydrous Cl3. So Cl3, it will take the Br, it will form the complex with the Br, and it becomes your convert into positive carbon. So there is a shifting of 1 to hydrogen, so it becomes your carbocation over here. Now this will attack our para position, because this is the ortho para directing group. This is the ortho para directing group. So definitely you will get compound. So this carbocation will attack at the para position of toluene, and you will get this product as a major product, and you will get other product CH3 at the ortho position, that is the minor product. So what is our answer to find the major products? So our answer in this case is C is correct answer. Next question, the major product in the following reaction is. So we can see this is the OH and carboxylic acid in presence of this is acetic anhydride in solvent is acetic acid. So in this case, what will happen? OH will react with the acetic anhydride and it will convert into the compound like this. Compound is this is the COOH, and this will be your OCOCH3, and this compound is a very famous name compound. This is called as the aspirin compound. So this is actually, this question came from the NCERT book. So this is the major product, and if you compare it, answer is B. Just see the mechanism how this acetic acid is reacting with the OH. So this is our answer. The compounds containing sp hybridized carbon atom is. So this is a lone pair. This will be your 1, 2, 3 sp3. One lone pair. So this will be your 1, 2, 3 sigma bonds sp2. This carbon will be C triple bond N and C. So definitely sp. And this have 2 double bond. This will be your sp. So 3 and 4 is sp. So this answer is correct. 54th, upon heating with acetic KMnO4, the organic compound produces hexane 1,6-dioic acid as a major product. What is the starting material? So they have given KMnO4. This is the hot KMnO4 acetic conditions. Heating, we are providing heat also, and it is converting into compound hexanoic acid. This is the OH, and this is again we can say OH. So 1, 2, 3, 4, 5 and 6, and this is only possible if you take the compound like double bond. So it will compound the acid and acid. So this compound nothing but the cyclohexane. It takes 1 hour for a first order reaction to go to 50% completion. The total time required for the same reaction to reach 87.5% completion. So this question is from the chemical kinetics, and this is the first order reactions, and we know that decay constant is equal to 2.303 divided by time taken, and this is log of initial value by the final value. So we have to find this decay constant. The decay constant for the two reactions will be same. So we will take this reaction separate, this reaction separate. So what is time given for the first one? It is a 1 hour. So right here 1 divided, this is the 2.303 divided by the 1 hour, and log, so initially is 100 and 50% is completed. Second thing, again this is constant, so 2.303 and divide by, so time they are asking, so time right here t, and log, so initially is 100 and how much they have completed, 87.5%. so 100 minus 87.5, so this will give you 12.5. so this will write here 12.5. so if you solve it, you will get the time is equal to 3 hours. So what is the answer? Answer is this one. A unit cell of calcium fluoride has 4 calcium ions. The number of fluoride ions in the unit cell is how much? So this is the calcium fluoride, and if you see the coordination ratio, it is coordination number is 8:4. So what does this mean? This means that each fluoride ion is surrounded by 4 calcium dipositive ions, and this fluorine is occupying tetrahedral site. So how many tetrahedral sites are there? So there are 8 present in FCCs, that is the cubic unit cells. So what is the question? Number of fluoride ions in the per unit cell is how much? So answer will be your 8. This is our answer. The equilibrium constant of a 2 electron redox reaction at 298 Kelvin is this much value. The cell potential and the free energy change delta G naught F for this equilibrium respectively are. So we know that the at equilibrium what happens? At equilibrium, so E naught of the cell is nothing but the 0.059 divided by, so what is the electron? Electron is given 2 and it is log of Kc. So Kc is given how much? The Kc is given 3.8, write directly value 3.8 into 10 to the power minus 5. This is the formula from the electrochemistry. If you solve it on solving, you will get 0.0295 into this is your 2, this is the negative sign, 2.42. So this will be the value 0 minus value 0.7139 volt. So we got one answer. This is what is the free energy. So free energy formula is delta G is equal to, so what is the value? So value will be your N F E naught. So what is the N value? So N value is your given here how much? It is given 2. F is how much? 96,500. And what is the this value? E value. So E value is given 0.071. This is the negative value. So you will get value. What is the value? You will get here minus. So okay, one thing forward. This is the formula. Minus is there. So right here minus, and this is also minus. So minus this comes here plus. On solving, you will get 13.8. This is your kilojoule per mole. So what is the answer? So one is negative, second is positive. So this is the correct answer. The number of stereoisomers possible for the following compound. This is the compound. So how many stereoisomers are possible? So this will give you geometrical isomers and this will give you optical isomers. So what is the formula? 2 to the power 1 for geometrical and 2 to the power 1 for the optical. So total is how much? 4. So our answer is 4. In the radioactive disintegration series thorium to lead involving alpha and beta decay. So what is the total number of alpha and beta particles emitted are? So we can find alpha particles. So this is 232 minus 208. This becomes your 24. And alpha particles, they have mass is 4 divided by 4, 6. 6 is the alpha particles. Now to calculate the beta particles, we got A and B options. 6 alpha particles for beta particles. 2 alpha minus B, and this is the 90 minus 82, because beta particles increases what? Atomic number by 1, and 1 alpha particles decreases atomic number by 2. So this is increasing atomic number, this is decreasing atomic number by 2. So 2 alpha minus beta, so you will get here how much? 8, and alpha we know how much it is. It is 6, it is 12. So beta will be how much? So it is 12 minus 8 equal to 4. So how much beta? So we are getting answer. This is a correct answer. In the following compressibility factor Z versus pressure graph at 300 Kelvin, the compressibility factors compressibility of CH4 at pressures less than 200 bar deviates from the ideal behavior. Why? Why it is deviating? So you can see it is deviating. This is by 200 bars, less than 200 bars. So if we know the compressibility factors, if it is less than 1, then this deviation will take place. And in terms of volume, we can write molar volume will be always less than ideal volume. This only possible when this condition is prevailing. So let us see what are the options. Options given here. The molar volume of CH4 is less than its molar volume in its ideal state. So this is totally agree with this concept. The molar volume of CH4 is same as that of ideal state. No, never. intermolecular interactions between the CH4 molecules, it decreases. No, it is increasing. It is not decreasing, it is increasing. The molar volume of CH4 is more than its molar volume in its ideal states. Molar volume of CH4 is more than, so this is wrong. This is not more than, it is less than. So this concept is again wrong. So only answer A is correct. X, Y and Z in the following reaction sequence are. So this compound is isopropyl benzene in presence of oxygen. So this is the compound they will form. Compound, this oxygen will get inserted between this hydrogen present as the benzylic carbon. So it will form the cumene hydroperoxide. So like this compound is formed. This is the cumene and oxygen get inserted like this one. So we'll get X is compound. So here if you see these options, A, we have option A, we have option B, option D. So our 3 X is this one. Now in presence of acid and water, so what will happen? This will convert into your phenol. So this is the commercial preparation of phenol, and OH will, again this OH will shift over here and this will release as the different group. So this will becomes OH, this will shift over this carbon and this will forms the compound CH3, CO and CH3. This will ask acetone. If you see carefully what is the answers. So first is your X is your hydroperoxide, A, R and D. So this given option. Second is your Y and Z. So this option is our correct options. Question number 102. The reagent required for the following two-step transformations are. So if you see carefully, we have to form this compound the two steps. So if you use HBr, so HBr it will react, it will undergo the Markovnikov rule. So it will form the compound benzene, and this will get the carbocations over here. This is the plus which attack with the Br, and this is the hydrogen. So we will get this compound. And again second step if you use NaCN, so this will undergo SN1 reaction. So you will get product this one. So first reagent is HBr and second reagent is sodium cyanide. So this benzyl peroxide, this will give you anti-Markovnikov rule. So this is not possible. Br2, Br will be added in both sides, again not possible. NaBr not possible. So answer B is correct. In the reaction sequence, this is the dialdehyde with benzene and with presence of concentrated potassium hydroxide in acidic conditions. What is the product X and Y respectively? So this will follow the intramolecular Cannizzaro reaction because the base is concentrated. So this hydride ion will transfer from here to here. So it will convert into alcohol. So first OH will attack over here. So base will attack over here. So it will convert into carboxylic acid, and this will then after hydride transfer from here to this compound. So X will get converted into compound. After hydride transfer, this will give you alcohol and this will give you carboxylic acid. So we have option A is there, C is there, and B and D is rejected. So out of these two options, now we have to do acidic hydrogen there. So this is the acidic. In acidic condition, if you heat it, then the OH from this side and hydrogen from this side will be eliminated out as the water, and you will get the product this one. So you will get product benzene. This is oxygen, and again this oxygen attached with this one and this oxygen. So our option is A is correct. In this reaction, benzene reacting with this anhydride. In presence of anhydride, AlCl3. So what will happen? This AlCl3 is in presence of this Lewis acid. One of the cleavage will occur over here, and this will attack in this pi electron. So pi electron will attack on this carbon, and you will get the compound like this. This is the CO, and you can get compound like this. Again, oxygen. So if we compare, so we will get the product A is there, only A is there. So we can judge that A might be the answers. So we can see this is not possible because this will attack at one position. And if you use the phosphoric acid, so what will happen? So this is the dehydrating agent. So definitely this will take OH. So OH is there. So again this carbon will attack over this ortho position, and you will get product. So it will aromatise the water, condensation will be there. So you will get, this is the oxygen, and you will get 6-membered ring, this one. So in this case again we have option A is correct. Next 105, copper crystallizes in a FCC lattice and has density 8.93 gram per centimeter cube. Radius of the copper atom is closest to. So density of the unit cell is nothing but the number of effective atoms in the unit cells divided by the mass of the unit cell and divided by the volume of unit cell. So this is nothing but the Avogadro number. So what is density? So density we can write. So it is given 8.93, and this is Z is for FCC is nothing but the 4, and mass is given here 63.5, is the mass of the copper, and Avogadro number 6.022 into 10 to the power 23. And what is the volume unit cell? So volume unit cell we don't know, so right here A is the length of the this FCC, so whole cube. Now if you solve it on solving, so A cube is nothing, so we can write this is the cube root, and this becomes a 4 multiplied by 63.5, and this is the G6.022 into 10 to the power 23 multiplied by 8.93. So on solving you will get what? So you will get again cube, this will be 254 divided by 5.358 into 10 to the power 24. So again if you solve it you will get answer cube root of 47.4 divided by 10 to the power 24. Means we can take out 8. So A is nothing but 3.57 into 10 to the power minus 8 centimeter. Now radius, that is 4r is equal to root 2a, or we can write r is equal to a by 2 root 2. So what is A? A is 3.57 into 10 to the power minus 8 centimeter, or we can write this is angstrom, and divide by how much? So it will be 2 into 2 root 2. So on solving you will get 127. So 1.27 you can say this is the angstrom, or 120. So let us write here. So 127, 1.27 is angstrom, 127 is the picometer. So which is the correct answer? So we have C is the correct answer. 106, given the standard potential of EMF copper 2 plus 2 copper and copper plus 2 copper, copper positive to copper is given this much respectively. So we have to find out the E naught of this one cell. So let us first write Cu2 plus, if you take 2 electrons it will give you copper. So in this case what is the G1? So G1 if you take it, so E you take E1, E1 will be of how much? It is 0.34 volt. As for 2 electrons we can multiply it by 2. Again for this one copper plus, so if you write copper like this direction, copper plus, take the oxidation potential, so it will be the reverse of this one. So reverse means it's negative 522, because this is the positive value. This is the reduction potential, we take the oxidation potential. Now if you add it, so on adding you will get copper di positive, and it is giving copper plus and this electron. So this is the, again we are getting this is the E, this is the again E, and this is the E3. Suppose this is the E2, this is E1. So now what is the total EMF of this one whole value? So we will take 0.34 multiplied by 2 plus this is a negative value 0.522, and if you calculate it, it will come 0. How much value? So 158. This is the volt. So which is the answers coming? Answer B is coming. This is the correct answers. For electroplating, 1.5 ampere current is passed for 250 seconds through 250 ml of 0.15 molarity solution of M sulfate. Means this is the dye positive. We can say that is the dye positive because sulfate, there is no sulfate is single entity, so it will be dye positive. So group 2 element is there. Only 85% of the current was utilized for electrolysis. What is the molarity of the this M sulfate, metal sulfate solution in solution? They are asking the molarity of the solution after electrolysis is closest to. Means this is the total moles, and if this is passed, this will be deposited on the plate, and you will get the remaining solutions. First, we have to find how much milliequivalent of this M sulfate is present in the solution. So this is how much. So milliequivalent present in the solution is in solution. This will be 0.15 into what is the volume, 250 divided by 1000. And again, if you take the milliequivalent, so you have to, this is the metal sulfate, so multiplied by 2 n factor. This is the total milliequivalent in solution. Now milliequivalent deposited, metal deposited. So how much deposited? So it is the this much value. So we take the ZIT. So ZIT means how much? So Z will be your equivalent will be how much? So it is current pass is 1.5 and it is 85% of current passed. And I value, this I given, and what is the T value? T value is given 250 seconds. And what is the Z value? So Z value will be divided by, we can say 96,500. This much is the whole value, whole deposited. And if you subtract whole this minus this, so this value is how much? This value is 0.75, and if you solve for this one, so you will get this value is how much? 0.0033. This is the total milliequivalent which is present in solution, present in solution, because this is deposited and this is in solution. If you subtract it, you will get in solution. So we have to, if you find it, what is the millimoles? So moles will be again 0.75 minus 0033, 33, and divide by 2. This is the moles. And if you want to find the molarity, so this is total volume is 250 multiplied by 1000. So this will give you total, give you your molarity. So if you solve it, on solving you will get answer 0.14 molarity. This much molarity is present inside the solution. Which of the option is correct? So if we see, we have option, this is correct option. The hybridization of the central atom and shape of IO2 F5 2 negative is that. So if you see carefully, so this oxygen to oxygen is most electronegative. So this should be symmetrical. This is not possible. This 2 oxygen this side, again not possible. So in this also 2 oxygen this side. So this is both are same. So it is rejected, and this is the most valid option, because 5 is in symmetrical structure and 2 is, so this is the most symmetrical, and this is giving the most stabilization of this IO2 F5 2 negative. So this is sp3d3, because again you can see carefully, iodine is occupying how much? 1 2 3 4 5 6 7 8 9 9, because it can expand its octet. So out of this 4 options, this is the most convenient and valid options for this molecule. So this is only valid answers. This iodine can expand, use 5s orbital, 5p orbital, 5d orbital, 5f orbitals. So all orbitals is fully utilized over here. And you can see there are 7. So 1 2 3 4 5 6 7, because this is pure orbital. Pi is 2 sigma modes and 5 sigma modes. So 5 plus 2 7. So this is only the correct answer for this one. The remaining is not correct answers. 2.33 gram of a compound X, empirical formula is given here. Upon treatment with excess silver nitrate solution, it is producing this much gram of a white PPT. The primary and secondary valency of the cobalt in compound X respectively are. So primary valency at the main valency, secondary valency at the coordination compound valency. This is the empirical formula of the compound. So if you see carefully, this compound is nothing but the CO, NH3, this is NH3 whole 4, and this is the Cl3. So we have to find how many Cl is going to be precipitate. So this compound is given 2.33. So we can say this compound is 2.33 gram. And if you take the molar mass of this compound, so it will come about, if you calculate, it will be again 233.5 gram. So this is nothing but 0.01 mole. And white precipitate, so this will, after reaction with the silver nitrate, so silver react with the Cl and it will give you this much gram. So how much silver chloride precipitate will form? So weight is given 1.435, and molar mass of silver chloride is again 143.5. So if you solve it, is again 0.1 mole. So 0.1 mole of this compound is giving 0.01 mole, means there is a 1 Cl is utilized. Means 1 utilized ionizable, remaining Cl is within the square bracket. So formula will become CO NH3 whole 4 and Cl2 inside and 1 Cl is outside. This is the basic formula. Now we will see what is the primary valency. Primary valency will be here, in this case 1, and secondary valency it will be of 6. So secondary valency is how much? It is 6, and primary valency is how much? It is 1. Now if you compare over answers, so answer 6 is matching, but this 1 is not matching. So this is you will get the bonus marks in your complete, because 3 is not possible over here. 3 Cl is not precipitate, only 1 Cl is precipitate. So instead of 3, I could suggest it should be 1. Though answer, this is it is not given completely, this is wrong answer, and this is not possible. So you will get the bonus marks in this question. The specific conductance K, kappa, K is kappa, of the 0.02 molarity aqueous acetic solution, acetic acid solution at 298 Kelvin is 1.65 multiplied by 10 to the power minus 4 Simon per centimeter. The degree of dissociation of acetic acid is, we have to find the alpha of acetic acid. So alpha formula is very well, so we know, so this is called molar conductance divided by the molar conductance infinite solution. We have to find this first molar conductance infinite solution of acetic acid. So what is the for acetic acid in this condition? So it is given over here. If you see examples, hydrogen is this much and acetate is this much. So you have to add it, 349.1 plus 40.9. So you will get how much? It is 391 Simon centimeter square per mole. So this is the Simon centimeter square per mole. So we know infinite value. How to find molar conductance? So molar conductance is nothing but the 1000 multiplied by kappa divided by C. So 1000, and what is the kappa value? So kappa value is given 1.65 multiplied by 10 power minus 4 and divided by your concentration is how much? It is 0.02. And degree of dissociation. So alpha is Vm by V naught. So this is the Vm. This is the Vm. And if you divide by V infinite, this becomes your alpha. So this whole value, if you divide by 391, okay, then you will get answer 0.021. So out of 4 options which correct, this is only correct answer. So these are the solutions of this KVPY papers of 2016.